Greetings, math fans. All right, so this is day 7. We're going to talk a little bit more about vectors. Okay, so just a couple things here. Remember, a vector has an initial point and a terminal point. Okay, and so this is a little wordy here, but I'm going to write this out. So in conjunction with the rectangular coordinate plane, okay, so in conjunction with the rectangular coordinate plane, the initial point is at the origin. Of course, being 0, 0. Okay, and then what the deal is called a position vector. Okay, so basically, if a comma b is the endpoint, okay, it is written as a comma b with these vector brackets. All right, and this is your x component, and the b is your y component. Now, math fans, this is really important. These brackets are super important. In fact, I'm going to put a couple of stars next to it. Okay, I think this is going to get 4 stars. All right, this is super important. You've got to put those vector brackets on there, because if you don't put the vector brackets on there and just use parentheses when I'm actually looking for a vector, I'm going to take a point off. All right, so you got to have that on there. And basically, this is what it looks like. All right, if you have a vector, basically I just call this vector a comma b. That's what that refers to, vector a comma b. And just to kind of, this distance here is, of course, a. It's your x value, and this distance here is your b value, and this is your theta. Okay, but that is it's super important you put that on there. Okay, very, very important. All right, let's talk about a couple different things now. First of all, let's talk about the magnitude, which is the length. Another word we use for magnitude is also the norm. Just another word. We'll see that later on. But anyway, the magnitude of vector u. So we're going to write this, and these absolute value bars, which not really are absolute value, it's what we refer to as the magnitude. That's what u, magnitude of u, is equal to the square root of, and I know I kind of erased this here, so I'll draw this back again. This is a comma b vector, right? Okay, but the magnitude u is equal to the square root of a squared plus b squared. It's just Pythagorean theorem. You're finding the hypotenuse. Okay? And the direction angle is found by tangent of theta, of course, this being theta. And we know it's y over x. So in this case here, it's going to be b over a. And a, of course, can never be equal to 0, or otherwise it's undefined. All right, and you guys kind of know that. It's pretty easy by just you look at the diagram and you already know tangent is y over x, and to get the hypotenuse, it's just Pythagorean theorem. All right, so it's pretty easy. The direction angle, this is important. The direction angle is a positive angle between the positive x-axis and the vector. All right. So in this case here, like the diagram that I actually have there, of course, it's going to be an acute angle, and then you can have it obtuse, reflexive. It can go into be in any quadrant. Okay, but it's always from the positive x-axis. All right, so let's do a nice little friendly example here. And if I ask you guys to find the magnitude and direction angle of -3, -4. Hey, again, it's really easy. And let's just say we'll say this is our vector. So u is -3, -4. And the first thing is we're going to find the magnitude of u, which is just -3 squared plus -4 squared. That's equal to the square root of 25, which is 5. So that's the magnitude. Pretty easy. Tangent of theta. All right, so this is the deal, math fans. Tangent is only going to give you a value, if you remember, inverse tangents from the last chapter, it's only going to give you a value between -π/2 and π/2, or between -90 and 90. So it doesn't, by me setting up tangent of theta is equal to and putting all the values here, it's only going to give me really the values between 0 and 90 degrees. Well, that doesn't really help because I need to know, in this case here, -3, -4 is somewhere in the third quadrant. All right, so I really need to know this angle here. So what you're going to do is you got to think back to what we did back in the day. This value here is always going to be positive. Because what that's going to allow me to do is, and I'm going to do this in red, that's actually going to give me theta prime. All right, so it's going to give me my reference angle, and then what I'm going to do is, of course, this is like back in the old days, if it's in the first quadrant, it's just theta prime. If it's in the second quadrant, it's 180 minus theta prime. If it's in the third quadrant, it's 180 plus theta prime. And if it's in the fourth quadrant, it's 360 minus theta prime. Okay, which kind of makes sense, right? If we're in the second quadrant and theta prime is 20 degrees, the angle is 160. Okay, it's got to be in that between 90 and 180. All right, so what you're going to do is, I even highlighted this here. This is always going to be positive. Very important. So I'm going to, instead of saying negative, right, it's y over x. So instead of saying -4 over -3, I'm actually going to say it's just 4/3. Now I know you're saying, well, isn't -4 over -3 already positive? Yeah, it is. But if it was, let's say one of them was positive, one was negative, you're going to have a negative value. And if you do a negative value, you're actually going to get a negative angle. Very confusing. You don't want to do that. All right. So theta prime is, if I take, of course, the inverse tangent of positive 4/3, right? That's how I solve for theta prime. I get theta prime is equal to 53.13 degrees. All right. And then basically what I'm going to do is, I know I am, as we said, we're over in this quadrant right here. And so we're going to do 180 plus, so this is actual value of, not theta prime. This is actually equal to theta. And 180 plus 53.13, which comes up to be 233.13 degrees. Okay, and that is your direction angle. Okay, that's pretty easy. But just remember, use positive values, get a reference angle, and then kind of deal with the reference angle. You know where you're at based on this guy right here. I'm at -3, -4. All right, it's not too bad. Okay. Let's then these next set of problems, this is what's going to happen. You're going to be given the magnitude and direction angle. And I want you to find the x and y components and write them as an ordered pair. which of course you guys know we're going to use our brackets. All right, so here's your first example. Theta is equal to 30 degrees. Okay, that's your direction angle. And the magnitude of vector V is equal to 105. Ooh, my favorite number. Sweet. All right, so, if I would just to make a sketch, just to kind of have an idea what it's going to look like, this is 30 degrees, and this is 105. Well, of course, it's kind of nice because this is a right triangle here, and this is your x and this is your y. So it's easy. It's our x component is equal to cosine of 30 degrees equals x over r. So x over 105. Cross multiply, and I wind up getting x equals 105 cosine of 30. So x is 90.93. Okay, that's pretty easy. Okay, now let's do our y component. And that's going to be sine of 30 degrees equals y over 105. Cross multiply, I get y equals 105 sine of 30. So y comes out to be 52.5. Now remember, your final answer is in brackets. Okay, so this is 90.93 comma 52.5 exactly. Right? It's pretty easy. Now, notice this is in the first quadrant. It's easy. It's all positive numbers. Let's do one that's not quite as friendly. Theta is equal to 170 degrees. And the magnitude of V is equal to 30. So again, if I would kind of sketch that, this is definitely not really to scale, but that's okay. It's 170 degrees, and this is 30. That's your vector V. Okay, and here's your y component, here's your x component. Now you're looking at it and going, oh, wait a second, this x, isn't that going to be negative? Yeah, it is, but you know what? It's all going to work out for us. The first is our x component, so we're just going to say cosine of 170 degrees equals x over 30. Now, I don't have to worry about trying to deal with any kind of reference angle here, math fans, because your calculator knows where you're at. You're at 130 degrees. So what do you think your calculator is going to give you, a positive or negative value? Of course it's going to give you a negative value. Cosine of anything between, or anything in the second quadrant is going to be a negative value, and it does. Okay, so you don't have to worry about any kind of reference angle. The only time you got to worry about the reference angle is when you're looking for the angle. Okay, then you kind of have to worry about it because the inverse trig function doesn't give it to you, doesn't give you every angle. It only gives you possibly in the first quadrant or in the first or second quadrant, depending on if it's sine or cosine. Certainly not going to give anything in the third and fourth quadrant. All right, cross multiply. I get x equals 30 cosine of 170. So x comes out to be negative 29.54. Okay, and then of course the y component is sine of 170 equals y over 30. Cross multiply, I get y equals 30 sine of 170. So y equals 5.21. Okay, and again, that's positive. Well, of course it's positive because y is positive in that quadrant there. So my answer is negative 29.54 comma 5.21. Okay, that's it, math fans. That's a pretty fast lesson. It's pretty easy. And again, this is just dealing with direction angles, and magnitudes. All right, that's it, math fans. Have a great day. Adios. Goodbye.